Hello everyone, for this video we will prove example 15 number 1. Tangent theta plus cotangent theta equals secant theta cosecant theta. So let's write it down. We want to prove this identity. So what we will do is we will start with one side and use identities to rewrite it in terms of the other. Take note that we are not allowed to transpose because we're not sure yet if this is an equation. So we can't use what we are proving. We can't use what we are proving to prove what we are proving. Did you get that? Anyway, so there are several techniques for solving these types of inequalities, rather identities. I hope you will see these techniques as you practice. In the meantime, for this type of problem, what we can do is we can express all the trig functions here in terms of just one trig function. Since we know that tangent and cotangent are reciprocal identities, it will be convenient for us to use the tangent function. Here we have two fractions, so all we have to do is combine them. You already know how to do this. Okay, at this point, what do we get? What can you say about the numerator? It belongs to a Pythagorean identity. We can rewrite it as secant squared theta over tangent theta. And from here, all we have to do is use the reciprocal identities. Secant squared theta is just 1 over cosine squared theta. And tangent theta is simply sine theta over cosine theta. Okay, so we just have to cancel. And we get the result that we want. Okay, next let's try to prove the second one. So 15.2. 15.2 is asking us to prove this. Sine to the 5th x minus cosine to the 4th x equals 1 minus 2 cotangent squared x over cosecant squared x. Okay. So this type of problem looks complicated. What we can do here is we can take each side separately and make both sides equal a common expression. If we are able to show this, then we can reason out that the left-hand side, should be equal to the right-hand side. To do this, let's express our equations in terms of sines and cosines and simplify as much as possible. Okay, so for our solution, for the left-hand side, what can we say about sine to the 4th x minus cosine to the 4th x? We may factor this into sine squared x minus cosine squared x, sine squared x plus cosine squared x. But you know that let's just copy the first one. The right hand expression is just equal to 1 because this is just equal to 1. Okay, so let's leave that in the meantime. For the right hand side, I can't remember what we have. Okay, we have 1 minus 2 cotangent squared x over cosecant squared x. Let's rewrite this in terms of sines and cosines. So we have 1 minus 2 cosine squared x over sine squared x. Then we have a cosecant squared here, which is just equal to sine squared x. Yes? This becomes this. So we can cancel. We will get 1 minus 2 cosine squared x Now let's go back to the first one. From here, we know that sine squared is 1 minus cosine squared x minus cosine squared x equals 1 to cosine squared x. So we were able to show that this is equal to this. Let's call this 2 asterisks is equal to 1 asterisk, and 3 asterisks is equal to 1 asterisk. Since we didn't even have to use multiple asterisks, since the left hand side is equal to asterisk and the right hand side is equal to asterisk, we can reason out that left hand side is equal to right hand side. Okay, this is 15.3, so let's just copy the problem. 2 plus cosecant theta over secant theta minus 2 cosine theta equals cotangent theta. Okay, so how do we solve this? Let's start with the more complicated side and rewrite it in terms of the simpler one. So let's start with the left side. 2 plus cosecant theta over secant theta minus 2 cosine theta. We may rewrite this using, let's rewrite it in terms of sine and cosines. We get plus, what's this? 1 over sine theta over, well, we have a secant theta here. So this is actually a times cosine theta. Then we have a minus 2 cosine theta. Then what do we notice here? We have a common factor, cosine theta. So we can factor it out. We will get 2 plus 1 over sine theta. Then this one, minus 2 cosine theta. Then from here, the remaining steps should be easy. Oops, this is supposed to be cotangent.